This lesson's on solving linear inequalities. So our objectives is that you can graph, write interval notation, and solve them right out. So on the number line, we saw this in class. If we want to graph x is greater than or equal to 3, draw a quick little number line here. I'm going to plop a 3 on it, circle it, and because it's equal to, we fill it in, and it's greater than, so we're going to shade it to the right. Now you can put other numbers on here if it helps you out, but you don't need to. Now what about part B? Graph x is greater than 3. As you recall, the one difference here is when I put the 3 here, circle it and shade to the right, I do not fill this in. Hopefully that makes visual sense here. Equal to 3, we include the 3. Here we go all the way up to 3, but we stop right short. So how do we write this in interval notation? Again, we saw this in class. Let me reproduce these really quick. So we have 3, is in, shade. So interval notation, again, just to remind you, we go left to right. So our interval notation is always left, comma, right. And then we either use a parentheses or a bracket depending upon if it's equal to or not. So in this one, it can be equal to, so we use the bracket, 3, comma, and we go all the way out to what number? All the way out to infinity. And there's our infinity symbol. So similar with x is greater than 3. Again, there's our graph. X is greater than 3. We're still going from 3 to infinity, but because it's not equal to 3, we use the parentheses to indicate that. And again, the infinity always gets the parentheses. There's one more notation that you may be expected to know in here, and that is the set builder notation. And all it is it uses this inequality here, and it just sort of dresses it up a little bit. So we use little curly braces. All x such that x is greater than or equal to 3. So it's always going to be all x if we're using x, that is. This is the set builder notation. So very similar on this one. All x such that x is greater than 3. Now when we solve inequalities, we solve them just like equalities. We solved a bunch of equalities lately. The only difference is we have to be careful about the inequality symbol. If we multiply or divide by a negative number, we have to flip that inequality symbol. Okay, so keep that in mind as we're doing these. So 3x minus 2 is less than 7. We want to solve that and write interval notation. So again, we're going to just solve this just like an equality, add 2 to both sides. 3x is, bring down the inequality symbol, less than 9. One more step, divide by 3. And we're going to get x is less than 3. So set builder notation, it didn't ask for this, but let's go ahead and practice a few of these. We just say all x's such that x is less than or equal to 3. It didn't ask for this, but I usually find it easier to go from the number line to interval notation than I do from set builder to interval notation. So we're 3, open circle, I'm going to shade to the left. So how is our interval notation going to be? The furthest left point is negative infinity. Make sure you say negative infinity. Comma, we stop at 3. So that is my interval notation. Again, it didn't ask for the number line. I gave it anyway. I wanted to give us one more practice with the set builder notation. Okay, how about this one? Example 4. Solve negative 3x plus 6 is greater than 14 and write an interval notation. So let's subtract 6 from both sides. So negative 3x's. Do I flip the inequality sign here? No. I subtracted 6 from both sides. I didn't multiply or divide a negative number. So bring it down as a greater than 8. Now divide by negative 3. I'm dividing by a negative number. So when I do that, I have to flip this inequality symbol. Again, optional here is to write this as a number line, so we'll say -8/3. Shade to the left. So interval notation, similar to the last one, we go -infinity, comma, -8/3. Again, it gets a parentheses. And these take a lot of practice. You know mentally now that you have to do this, but it's really easy to forget when you're in a sea of other problems and that this happens to come up. So really try to remember that. Maybe we'll do an in-class activity that helps concretize that. Okay, go ahead and pause the video here. See if you can do this one on your own. We just have 2 more examples, I think. All right, welcome back. So here I'm going to get all the x's to one side. I generally get the x to the left side as quick as I can, so I'll subtract 5x from both sides. And we'll do this in 2 steps. So 4 minus 7x is greater than or equal to, those canceled, 3. Let me subtract 3 from both sides. Sorry, 4. So those 4's cancel here. I've got a -7x is greater than or equal to 3 minus 4 is a -1. All right, we're almost done. Divide through by a -7. Those cancel. I'm divided by a negative again, so I have to remember to flip this inequality sign. A -1 over -7 is going to be a positive 1/7. On the number line, x is less than or equal to, so I fill it in and go to the left. And so we're going from -infinity, again the infinity always gets the parentheses, comma, 1/7, and because it can be equal to it, it's filled in circle, we're going to use a bracket there. So that again is my interval notation. Okay, last example. Kind of a wolf in sheep's clothing here, so go ahead and try to solve this one and write an interval notation. All right, welcome back. So what do we have here? Simple enough, we're going to divide through by 2. And so 8 divided by 2 is 4. Keep the inequality symbol just the way it is. Now what happens when we graph this on a number line this way? Which way am I going to shade? I bet many of you shaded to the left. Hopefully you didn't, but I bet it's a very common error. We always read from the perspective of x. So this is x is greater than 4. Don't read it as 4 is less than x. You can read it that way, but most students, when they do, will misgraph it. This is why I almost always will rewrite these with the variable on the left. So this is x is, and the greater than is still on the x, 4. When you write it this way, it's really easy to see which way to shade. So 4, comma, infinity. Both of them get the paren. So really be careful on those. Inequalities are not too bad. If you can solve equations, you can do inequalities. They do involve a couple things to remember. One, when you multiply or divide by a negative number, you flip the inequality symbol. A couple other things is how to graph it and interval notation.